Okay, so in the question here, let us understand the condition for the first minima in a diffraction pattern. So let us take EI as the slit on which a monochromatic light from a distant source is incident. Now as per Huygens principle, each point on the wavefront at EI then becomes a source of secondary wavelets. So if we take a point P on the screen, then rays will reach at P from all these point sources on EI. Now let us take the point P such that the rays from the ends of the slit, that is NE and I, to P, that is rays EP and IP, have a path difference of lambda, that is length ID here is equal to lambda. Now do note that the distance of screen here is much larger than the slit width and wavelength of light. So we can take these rays EP and IP as nearly parallel. Now as a next step, let us divide the slit into two equal halves, EC and CI. So in the similar triangles ECK and EID, EC upon EI is equal to CK upon ID. And since EI is twice of EC, implies CK is half of ID. That is, length CK is equal to lambda by 2. That is, the rays from E to P and C to P will have a path difference of lambda by 2, which implies they will have a phase difference of pi at the point P. So in the ray picture, if you see, the ray EP and CP will have a phase difference of pi, and that means the two rays will be totally out of sync when they meet at P and hence will cancel each other at P. So the point to note is that in our scenario here, when the sources are a distance a by 2 away from each other, the rays from these sources, when they reach P, have a path difference of lambda by 2 and they cancel each other. Now EC is equal to CI. So if we take any point source on EC, say S1, then for that source there will be a corresponding point source S1 dash, a distance a by 2 from S1 in part CI, and the rays from S1 and S1 dash at P will have a path difference of lambda by 2. And when they interfere at P, they will interfere destructively and cancel each other at P. And the same intensity cancellation at P will happen for the ray from every point source on EC by the ray from the corresponding point source a distance a by 2 away in CI, and therefore point P will be a minima and it is the first minima. Suppose, so the condition for the first minima is that it will be at a point P such that the rays from the two ends of the slit E and I to P have a path difference of lambda. Now in the video 040, let us measure the angular position of the point P with respect to the center line and the distance of the point P from the center point O.